Intermediate Algebra for Statistics, Integer Exponents, Part 3. Lesson Objectives: Simplify expressions involving negative integer exponents. Use models whose equations involve negative integer exponents. We'll begin by reviewing the definition of a negative integer exponent. If you recall, if b is not equal to 0 and n is a counting number, then b to the negative n power is equal to 1 over b to the n. To find b to the negative n power, take its reciprocal and flip the sign of the exponent. Let's sort of see why this is the case. So if we were to write 1 over b to the negative n in another form, where n is a counting number, so 1 over b to the negative n is the same thing as 1 divided by b to the negative n. b to the negative n, by definition, is equal to 1 over b to the n. And if you remember how to divide fractions, this value stays the same. We change this to multiplication, and then we flip this. We do the reciprocal. So this will become 1 times b to the n over 1, and then that's equal to b to the n. So let's define this and do some examples. Definition: if b does not equal 0 and n is a counting number, then 1 over b to the negative n equals b to the n. We want to move the base across this line to change the sign of the exponent. In words, to find 1 over b raised to the negative n power, we take its reciprocal and we switch the sign of the exponent. For example, 1 over 2 raised to the negative 4 power, we want to move the base of 2 to the numerator, and that will change its sign, and we get 16. 1 over b to the negative 8, we move it up to the numerator, and we change the sign of the exponent. Let's do some more examples. Example 5. Simplify number 1, 9b to the negative 7, 2, 5 divided by b to the negative 3, and number 3, 3 to the negative 1 power plus 4 to the negative 1 power. Solution: so for number 1, the 9 is a base, b is a base. For the base of 9, the exponent is a positive 1, so it's okay. For the b, it has an exponent that's negative, so since it's in the numerator, we send it down to the denominator, and then that is equal to 9 over b to the 7th. This has a positive exponent. The b now has a positive exponent. Number 2, 5 is a base, b is a base. This is a positive 1. To make this exponent positive, since it's in the denominator, we send it up to the numerator, and we get 5b cubed. We are finished. Number 3, 3 to the negative 1 power. It's in the numerator, so we have to send it down to the denominator, plus 4 is a different base. So for the base of 4, it has a negative exponent. It's in the numerator. We have to send it down to the denominator. So 1/3 plus 1/4. We have to get a common denominator of 12, and that gives us 7/12. Properties of integer exponents. So the 5 rules that we had before for counting numbers also hold for integers. If we have like bases and we're multiplying, we add the exponents. If we have like bases and we are dividing, we subtract the exponents. If we have bases to a power, that power distributes both bases. If we have a base divided by a base raised to a power, that power is distributed to both bases. And if we have a power to a power, this is when we multiply the exponents. Let's do an example. Example 6. Simplify number 1, 2 raised to the negative 1003 power times 2 to the 1000 power. Number 2, b to the negative 6 divided by b to the negative 4. And number 3, 35 b to the negative 9 c to the third power divided by 25 b to the negative 7 c to the negative 5. Solution. So number 1, we have a base of 2 and a base of 2. So now we add the exponents. So negative 1003 plus 1000 is 2 to the negative 3 power. This is a negative power. We want to make it positive. So since this is in the numerator, we send it to the denominator. Or you can think of it as we're doing the reciprocal. And then we change the sign of the power. 1 over 2 to the third is 1 over 8. Now if you try this on your graphing calculator, these values are too big. The calculator can't compute it, and you will get what is called an error for overflow. That means the number is too large for the calculator. So using property of exponents, we can actually compute values that the calculator cannot compute. Number 2, these are the same base, b, and since we are dividing, we will subtract the exponents. So this now becomes b to the negative 6 minus a negative 4. Subtracting a negative number becomes addition. So negative 6 plus 4 is a negative 2. To make the negative 2 positive, we do the reciprocal and change the sign, and we are finished. Number 3. First, simplify the bases of 25 and 35. 5 will go into 35 7 times. 5 will go into 25 5 times. Then we have a base of b, so this will be negative 9 minus a negative 7, and then this will be, for the base of c, 3 minus a negative 5. So the only thing that we have in the denominator is our 5. We have 7 in the numerator, b in the numerator, c in the numerator. Negative 9 minus a negative 7 becomes negative 2. 3 minus a negative 5 becomes 8. So this has a positive exponent, this one has negative, this one has positive, and this one has positive. So our last step is to send the b down to the denominator and change the sign. So we now have 7c to the 8th divided by 5b squared, and we are finished. Example 7. Simplify this expression and this expression. So for number 1, since we have an expression to a power, we want to distribute the 2. So base 3 has an exponent of 1, base b has an exponent of 1, base c has an exponent of 5. So each power will get multiplied by 2. For the denominator, base 2 has an exponent of 1, b has an exponent of negative 2, c has an exponent of 2. Every power will get multiplied by 3. So for the numerator, we have 3 squared, which is 9, b squared, and c to the 5th squared. So this will become c to the 10th. Then we have 2 to the 3rd power, which is 8, b to the negative 2 raised to the 3rd power. So now we will multiply these two values and get negative 6, and c squared to the 3rd power, we will multiply these and get a positive 6. Next, we have like bases with the b's and like bases with the c's. So on the next slide, we will subtract those. So we have b squared minus negative 6, and we have c raised to the 10 minus 6 power. Subtracting those, we get 9b to the 8th, c to the 4th, all divided by 8. There are no parentheses, there are no negative exponents, and all the bases are different. We are finished. Number 2, our first step is to simplify what's in the parentheses first. 18 and 6. 6 will go into 18 and 6 will go into 6. So this will become a 3. This will become a 1. And 1 times b to the negative 3 is b to the negative 3. So we'll have a 3 in the numerator, and the 6 will disappear from the denominator. Next, for our b, we'll have negative 4 minus negative 3. And for base c, 7 minus 2. So now we want to simplify the arithmetic. We have 3 b to the negative 1 c to the 5th, and this is being raised to the negative 4 power. Every exponent will get multiplied by negative 4, so this will be 3 to the negative 4 power, b to the negative 1 times negative 4 power, and c to the power of 5 times negative 4. Multiplying, we get 3 to the negative 4 times b to the 4th, because a negative times a negative is positive, and positive 5 times a negative 4 is a negative 20. So 3 to the negative 4th will be sent to the denominator, c to the negative 20th will be sent to the denominator, and we will change the signs of the exponent. So our answer will be b to the 4th over 3 to the 4th times c to the 20th. Our last step is to compute 3 to the 4th, and that's 81. So the final answer is b to the 4th divided by 81 times c to the 20th. We are finished. Thanks for watching.